Okay, so here it says SAT scores of students at an Ivy League college are distributed with a standard deviation of 250. Two statistics students, Raina and Luke, want to estimate the average SAT score of students at this college as part of a class project. They want their margin of error to be no more than 25 points. Raina wants to use a 90% confidence interval. How large of a sample should she collect? So this is going to come straight from the notes. The formula for the sample size of a confidence interval. Let me pull that up real quick. Okay, so this is copied straight from the PowerPoint notes in the course materials. It is from slide 29. It gives you the sample size needed to find a confidence interval given the standard deviation. So since we know the standard deviation is 250 points, this is the formula I'm going to use. So we have here, this is 250. The margin of error is going to be 25 points. And we're trying to make a confidence interval of 90%. So I have to figure out the Z alpha over 2 value that cuts off the middle 90%. So if I draw the normal curve, I'm looking for the Z values that cut off the middle 90% or 0.90. If there's 90% in the middle, that means there's going to be 5% on either side, totaling a total area of 1. So when I go into the calculator to find this Z value, I'm going to go to inverse normal. The area to the left of this Z value is 0.95. Mu is 0, sigma is 1 because it's standard normal. It's Z values. So that's 1.6448. Okay, that's this value. So I'm going to just do it all in the calculator. The numerator of my equation is the Z value times standard deviation. So we'll do times 250 divided by the margin of error, which is 25. And then I'm going to square this thing. So I get a value of 270.55. So when you're finding confidence intervals, just to make sure that your confidence interval is in fact large enough, no matter what the decimal is, if there's any decimal at all, this could have been 270.1. You always want to round it up because if you round it down, it might then make your sample size too small. So just to verify that it is in fact large enough, we round that up to 271. I mean, we would regardless, but if this was not a 5, this was a 3, 2, or 1, we would still round it up. So we have 271 people. Luke wants to use a 99% confidence interval. So he wants to be more confident. Okay. Without calculating the actual sample size, determine whether his sample should be larger or smaller than Raina's. He wants to be more confident. Okay. If we're increasing his confidence level, then we want our sample size to be larger. If we ask more people, the results we get from asking more people will solidify our confidence. So if we raise the confidence level, then we're going to select a larger sample size. Well, no, this says higher degrees of confidence require larger margins of error. We're not talking about margins of error here. Should his sample these are poorly worded. It should say larger because higher degrees of confidence. This is the answer, but there's not a question like that hopefully on the problem set. I will verify that, and if there is, I will give you the points back for that. But I would disregard this question right now because these are worded very, very poorly. If he wants to be more confident, then we'd have to have a larger sample size. So then we could do the same thing and figure out the sample size for Luke. So the only thing that changes is this Z of alpha over 2. So this is now 99% in the middle, 0.99, which means this is 0.005, and this is 0.005. So the area to the left of this z value is going to be 0.995. So if we rerun that, inverse normal, we replace that with 0.995, we get this new z-score. So then we times it by 250, divided by 25, and then we square that. We get 663.4. So this one we would normally round it down to 663, but we always round it up to 664. Okay, but I don't like this question. I would disregard the sentences after, but just go with the fact that the sample size has to be larger. Or, I mean, if you could just calculate the sample size and see that since we had a larger answer, it must be this answer. But I don't like these choices.